Alright, welcome back everybody. This is lesson number 5, Graphs of Polar Equations, and this is also the very last lesson of pre-calculus. So we've made it. This is going to be a pretty fun lesson to do for a grand finale. Polar equations, the graphs are really neat. We're going to need polar planes, so make sure you get a couple of polar planes available to graph on. We're also going to want to have a calculator handy. I'm going to be using my cell phone and Desmos. If you want to use one of the school calculators, I can show you how to do this process using the school ones at school. If not, use your phone and Desmos like I am. So, the other thing that we're going to need is this table of values. So, pause the video and copy this down and resume when you're ready to move on. Alright. So, polar equations have an r value, which would be our radius, which we already knew that, and some sort of theta value. We have picked a lot of theta values to evaluate, and we're going to be making our way around this polar coordinate plane by marking whatever we get out for r. And what we're going to see are some pretty cool looking designs, stuff that you don't usually think of when you think of graphs, because you're not supposed to be getting loops and that type of stuff. But we're going to see some pretty neat graphs on these problems. So, one other thing before I start. There is a reference sheet on the website, if you wanted to look, that will give you a clue as to what the function itself could look like, or like the general idea of what that would look like. So if you want to have that reference sheet, you can also print that out. It's not really necessary. These are pretty neat because you can, it's kind of like a surprise when you get to see what they look like. So let's open up Desmos on our phones if you're going to be using that program. And we're going to type in the equation that we see here. 2 plus 3 cosine. And we're going to just start punching in all of these values. So first we have 0, and it comes out to 5. Then we're going to punch in pi over 6. So delete pi over 6. We don't have to be exact here, right? We see 4.59. 4.5 is close enough. Okay, we don't have to be 100% accurate with these decimals. So just, be aware of that when you start looking at solutions that I'm going to show you. Depending on how you round, it's not a big deal for these problems. Okay, now we want pi over 4, so we're just going to backspace and click 4. We get 4.1. Okay, backspace, pi over 3, we get 3.5. Now we got pi over 2, which gives us 2. And we're going to keep on doing that for each of these values. Now, though, we want 3 on bottom, and we're going to just click so that we're on top. We can put the 2/3. It's going to give us 0.5. Really, it should be 0.5, but I've kind of got a small table here, so let's see. We want this to be 3 over 4 is our next one. Negative 0.1. Okay, next would be 5 pi over 6. It's looking like negative 0.5-ish. Negative 0.6, negative 0.5, it's close enough. We don't have exact measurements on here, so. Alright, let's see. We want pi, right? Pi. So if we do 6 over 6, that's equivalent to just pi. And that gave us negative 1. Okay, plus we want to do 7 pi over 6 now. So negative 0.5 again. 5 pi over 4, negative 0.1. 4 pi over 3, we get 0.5. Go now. 3 pi over 2 gives us 2. 5 pi over 3 is giving us 3.5. I've got a couple more to go. .1. 11 pi over 6, that's around 4.5-ish. What do we have before? Yeah, 4.5-ish. And 2 pi. If we were to do 12 over 6, that's equivalent to 2 pi. So we get 5 here. Now, we're going to look at the graph of this. Okay? We don't need the equation anymore. We do need the table though. Notice how we're starting at 0, and we're going to be working our way around. These are not going to be straight lines. You're going to do your best to kind of make a nice smooth curve, because these shapes should be nice and curved, or figures should be nice and curved. Okay, one thing I'm going to point out before we graph: 0 and 2 pi are the same spot, so it should be the same result when you plug these in. So this is something you want to make sure that you have the correct, because you might have typed in something wrong. These should always match. Okay, so at 0 radians, we're at 5. 1, 2, 3, 4, 5. Okay, pi over 6, we got 4.5. So let's see, this is pi over 6. Here's 4, here's 5, right about here. Then 4.1. It's a little bit above 4. 3.5. Here's 3, here's 4, here's 3.5. Then we got 2 at pi over 2. That's right here. I'm going to start drawing in some of this right now, so I can see the general look. I want to make sure that that's as smooth as I can make it. And of course they come out like straight lines anyways, but that's alright. So let's see, we got a couple more to do. 2 pi over 3, which is right here. They give us 0.5. Here's 1, so 0.5 is right there. Then at 3 pi over 4, they give us negative 0.1. So remember, we're going to be following this line, but we're going away from it, 0.1. And 0.1 is just a little bit past the center. Okay, 5 pi over 6. Here's 5 pi over 6. We're following it out to negative 0.5. So that's about right here. Alright, continuing a little bit more of my graph now. We're going like this. Okay, starting to kind of curve in. Let's see, pi, we're at negative 1. So here's pi, negative 1. 7 pi over 6. Here's our next one, 7 pi over 6. We're at negative 0.5. So follow it and go past a little bit to out here. Oh, so now look what's happening, right? It's going back in. 5 pi over 4, we want negative 0.1. So follow this all the way to right here. 4 pi over 3, we're getting 0.5. Here's 4 pi over 3. We're right about here. So now we just hit here, so now we're crossing back over. So notice how we have this nice little loop-de-loop inside. Okay, then we got 3 pi over 2 as our next coordinate at 2. 3.5 for 5 pi over 3. So here's 3, here's 3.5. 4.1 for 7 pi. 4.5. So here's 4, here's 5. It's right about here. And then we end up at 5 for 2 pi. Here's 2 pi. Bam. Right like that. Pretty neat looking graph. Okay. We're going to see some really funky looking stuff just like this for the rest of this lesson. Now, here's what I've done for you. I'm going to make this video nice and short from here on out because this is the last one and I'm sure that you don't want to sit through another 45-minute one. So, I'm going to show you the equation in just the table so that you can copy it down if you need to. Okay, and you're going to evaluate this function, okay, at each of these values. Then pause it when you're done, and I'm going to move this away and you can check it. And then you'll graph, and then you can check the graph with me afterwards as well. I'm going to do the graph part out with you. So pause the video, find all of these solutions, and then when you're ready to check them, resume. Okay, here are the values. You were supposed to have done this on your own. So you're just checking these. Now remember, you can be a little bit off from what I have. So if you had like 0.4 instead of 0.5, that's fine. 0.7 or 0.9, whatever. It's pretty close. Okay, we don't have to be exact. Also, this is an 8. Okay, it just came out really ugly looking. So these are the values you should be getting here. We're going to graph this now. If you want to pause the video on your own and graph this, that's up to you. I'm going to do one more before I have you do them on your own anyway. So here we go. At 0, we're out here at 4. Which, by the way, that matches, which is a good thing. Pi over 6, we're at 2. So 2 is right here. Oh, yeah, that's 2. Then 1.1. Here's 1. Here's 1.1. 0.5. And then 0. So here's what's happening. It's kind of jumping out like this and then curving back in. Then at 2 pi over 3, we're at 0.5 again. So out to here. 3 pi over 4, we're at 1.1. Right about here. Then we're at 2. Oops, I put that on the wrong lines. That's here, and that's here. Really tiny, it's tough to see sometimes. And then we're at 4 for pi. So 4, this is 2, 3, 4. Okay. If you make a little error like that, hopefully you're using pencil, just erase it. If you're using pen, don't worry about it, just don't connect it. Right? Now we want to do the next couple. So we're at 6 at 7 pi over 6. 7 pi over 6. Here's 6. Then we're going even further out. 6.8. It's like right around here. Then 7.5. And then 8. And then it starts coming back in. 7.5. 6.8. 6. And then back to 4. And you just made a heart. Okay? So, the next few, I know the sentence I said about this was jumbled before. The next few, you're going to do exactly what you did before. You're going to write this down, okay? Figure out all these values. Pause it. Once you get them, resume, and then you can check. So pause the video, do this problem, fill this table out. Okay. Now you've filled out this table. I want you to check your solutions. Once you have that, right? Once you have these, check these, pause the video, and then graph, and then you can check your graph after. Okay, so hopefully you've checked these, and then you've graphed already. I have not. So, let's see what this graph looks like. 0, we're at 5. Then we're at, whoa, 0. So we went from here to here. Now, I'm not 100% sure what that's going to look like quite yet. But, let's see what some of these other things kind of look like. At pi over 4, we're at negative, so we're going out 3.5. 1, 2, 3.5. Alright, so here's what just happened. Now remember, this isn't just going straight. We are going along this circle's edge here, right? But it's eventually going to come back in. So it's going to kind of do this kind of hook. It's going to come out and then hit. Okay? Just like that. And then it's extending out to here. And then it goes a little bit further. Pi over 3, we're at negative 5. So we're following this. We're going out to 5 right here. So here's what's happening, right? It's kind of going like this, and then comes through to 5. And then all of a sudden, at pi over 2, it jumps back to 0 right here. So we can kind of see what's happening, right? This thing's kind of going like this. Then at 2 pi over 3, we're at 5. So let's see, 2 pi over 3, we're at 5. Okay, so let's see. We know the general idea. This thing's going like this. Now it's coming back. So it's going to be swooping around just like this. Okay, we want 3.5, so it's starting to come back in. And then it hits 0 again. Bam. And at pi, we're at negative 5. Pi, negative 5. Now I can see that all of these basically are repeating, except that the signs have changed, right? These are now positives, and then these two are now negatives. But that's okay, because these are on the opposite side of the circle. So what would happen is that when we start doing these values over here, we're going to be going, you know, following these signs. It's going to put us back on some of these places that we already were. Okay? These ones, it's going to be going the opposite side, and it's still going to end up putting us back on. So we can see that these things are basically repeating right here. So this thing, it does its really cool little three-way loop, and then it does it again. Okay, so this one's all done. Got one more. Oops, I'm not supposed to show you the answers to it yet. Okay, you got one more to try. Pause the video, resume it when you're ready to check this table. Okay, let's check out your table. Pause the video, check those values. Okay, now you're going to want to try and graph this. Pause the video, graph it, and then you can check it with me after. Alright, got one more to go. This is it. This is the final problem. Alright, at 0, I'm going to have to move this over here because I just don't have the space. Sorry. So at 0, we're at 0. So 0, 0, didn't go anywhere. At pi over 6 here, we're at 5. So let's see. Pi over 6 is at 5. Okay. How would this start to look? I'm not quite sure yet. So I'm going to graph some other points to see exactly what's going on. Pi over 4, we're at 6. So here's pi over 4. And then pi over 3, we're at 5 again. And then we go back to 0. So we're back to 0. Okay, so I can see what's going on here. Right, it's kind of going like this. It's jumping way out, hitting, and then coming back. Right like that. 2 pi over 3, we're at negative 5. So here's 2 pi over 3. We're going to go opposite. 1, 2, 3, 4, 5. So we're right here. Then we get 3 pi over 4 at negative 6. So here we go. Following that out to negative 6. And then negative 5. So let's see. 5 pi over 6. Negative 5. So this is what's happening, right? It goes like this. It hits. And then it comes back for another loop out here. And then it comes back. Now I can kind of guess what's going to happen, right? I can see it going like this. It's going around. It's probably going to either do this loop here or this one up here. So let's see. 7 pi over 6, we're at 5. So here we go. 7 pi over 6, 5. Yeah, this is more predictable. I kind of figured it was going this way. Then we're at 6. Then we're at 5. Okay, here we go. Okay, and we got one more set. Negative 5, right? And we kind of knew it was going to end up over here. So let's see. 5 pi over 3, negative 5. Is right here. And then follow this to negative 6. And then our very last point right here. And then again, this is going to land us back here at 0. Okay. I'm going to show you one more quick thing, which I think is really neat. It's what these things look like on your Desmos calculators. You can't do these on the school calculators that we have. I mean, I'm sure you can get an upgraded version and find it, but we don't have them at our school. So we're going to want to change this to a polar grid. So you click on the little wrench and you see grid, click on polar. Okay, so now we have our polar axis. And he's even got like the little labels for us too, which is kind of cool. Okay, let's see, how far out does this go? Here's 10. Let's zoom in so we have, oops, we're up to 8. Oops, let's zoom in a little bit. Oh, this is tough. A little too far. Too much. I should have done this before. Alright, here we go. Here we go. That's got a good amount of stuff to it right there. That's a pretty good one. So now, here's our polar axis. Here's our function. It's calling for R. So I'm going to type in ABC. I'm going to type R back to my function and the equals. Okay, then it also calls for 2 theta. Right, so 2, and theta is, let's see, right over here. So we clicked on my alphabets, and it's right here above the little arrow. 2 theta, and whoa, there you go. Oh, we forgot something. This is the wrong function. Let's see, we gotta put in the correct function, Mr. Marchetti. We were doing R. Where's R? R equals, here's our function, 6 sine of theta. Nope, 2 theta. 2 theta. There you go. So you can check them. I mean, you have to make sure you type in the right function, but you can check them. So now that you've done the very last problem, and I've wasted an extra, looks like 4 minutes messing around with this, we're done. That is pre-calculus. You have just completed an online course of pre-calculus. Good for you. Really, that's some tough stuff. I want to just say real quick, I'm dedicating this particular video to Central High School's class of 2020 because they really asked me to make this website for them, and I pushed myself to get this done before the end of the year for them. So this is dedicated to you, class of 2020, Central High School. Alright, well, who knows, maybe I'll make one of these for like Algebra 2 or Calculus or something, I don't know. If you like these videos, just let me know in the comment section somewhere, I guess. Alright, till next time.